All right, guys, well, we're going to get started here. Thanks so much for coming to our session here. I know up on the 5th floor, we're probably second only to the 3rd floor in terms of people going to the wrong places. So thanks for finding us. My name is Jay Marshall, Principal Strategic Advisor on Google Cloud Platform. Joined by, actually, we have a whole crew here, so I'm going to let everybody introduce themselves as we go. But it's going to be a little bit of a different session here today. How many folks here have actually logged in and tried Google Cloud Platform yet? Oh, that's awesome. So I can just give you 45 minutes back if you want, if you already are familiar with the platform. Hopefully it's a good thing then that you're here, if you've tried the platform out and decided to show up. We're going to do this in a little bit of a different way. I think to Brandon's comments earlier on this morning in the keynote, one of the big things that we're really trying to drive home about GCP is how we're kind of approaching the cloud compute market a little bit differently than maybe what a lot of folks are used to. And it's really about the open APIs, open source, so on and so forth. And it sounds a little bit marketing at the bottom here when it says that customers should use us because they love us. But we did talk about Hug Ops this week, so hug, love, it all kind of goes together, right? But it's also very true. I think at Google, we consider it to be our responsibility to prove ourselves as not only price performance leader, but also ease of use, quality of the infrastructure, so on and so forth. So to give you one quick example, you might see HBase up here. You might think, okay, well, how are you supporting something like an HBase? Many of you might be familiar with the fact that HBase was born off of the Big Table white paper that Google wrote back in the mid-2000s. So when we decided to actually externalize Big Table and start letting other people rent it off of us, essentially, we didn't actually expose the internal plumbing. We said, look, there's a whole ecosystem out here around HBase. So we actually use the HBase API to front end our Google Big Table service. So that's just one example. Kubernetes, obviously, another good example. And of course, down here in the lower left-hand corner, we have Chef. So although we've had different recipes and different, the knife plugin for Google, GCP, so on and so forth, we've really been doing a lot more focusing in the last, say, 6 to 12 months around how Google engineering, Chef engineering, and the partner ecosystem, how we're all collaborating to show a lot more love and a lot more hugs to Chef and the Chef ecosystem. So that's what we want to show you today. So since a good food metaphor never gets old here at ChefConf, we're approaching this kind of, I'm a foodie, probably no big surprise there, but so if anybody watches like Top Chef or any of the cooking shows, they do things like something 3 ways, right? So we're going to do Chef and Google 3 ways. So for our bacon rack pork tenderloin, that's going to be Chef Automate or Chef Delivery or Chef Workflow. I get confused, I'm sorry. It was just yesterday. I haven't finished baking it in yet. And App Engine. So App Engine was kind of our foray into cloud computing, right? We actually started with App Engine back in 2007, 2008. We just kind of got it wrong, right? Y'all wanted virtual machines and networks still. So App Engine's been around for about 8, 9 years. If anybody here uses Snapchat or if your kids use Snapchat, that runs on App Engine, right? Very popular, very large platform as a service offering. So from Chef, the lovely JJ, and the also lovely Nelson from Google, 2 of the engineers actually working on that are going to give you a demo and show you what we've done and collaborated on there. And then for our candied bacon, my personal favorite, we're going to actually do a little bit more of a deep dive review on, once again, why does Google Cloud and our platform differentiation matter to Chef? Or why do we think it should matter? And then finally, for our 3rd course, our bacon and tomato pasta sauce is actually going to be us working with one of our partners, very well-known Chef Bar Cascadia, working on a multi-cloud scenario of where maybe you want to use not only Google Cloud, but other cloud providers and maybe your private data center on a real-world customer example of being able to collaborate across multiple clouds. Because once again, us winning doesn't mean other clouds lose, right? Everybody that we talk to has a multi-cloud strategy. So to us, how do we become part of that multi-cloud strategy? So that being the case, I want to turn it over to the stuff that you guys really care about. So Nelson and JJ, introduce yourselves, and we're going to look at Chef Delivery on App Engine.
Mike, go ahead.
Oh, there you go.
So I'm Nelson Araújo, I'm a developer at Google, and I've been collaborating with Chef for us to build this demo. So the idea here is we are going to use Chef Delivery to roll out an application update and make sure that as developers usually do, they make mistakes and totally, obviously, well-explained mistakes. But we don't want the infrastructure to suffer as that happen, right? We want to make sure that we have a consistent pipeline delivery, and we are going to do that along with the delivery. So it will be an end-to-end demo from all the way from I have my application running all the way to I have my application updated.
Cool. And hey, my name is JJ, also known as J Dizzle. No, not really. There we go. I got to laugh.
Sippy cup.
Sippy cup. Yay. Okay, so we set up a delivery cluster, or I'm sorry, an automate cluster. I'm going to call it delivery. We set up a delivery cluster, and this is our application. We've created a GitHub repo with our application, which, as you see, is a pretty straightforward Python app that does the thing. So Nelson, as my developer, is like, JJ, this kind of sucks, doesn't it? We need to fix this.
Exactly. Well, it works, but it doesn't look good. It doesn't look pretty. We need to make this better. And this is currently running on App Engine. So let's open the App Engine console. Mm-hmm. And you have here the official app and the only one version deployed right now.
Right there.
Right, so if we can create a pull request so we can get my awesome change going. Well, we can.
Yeah, it's on your opt-out.
Can do that. Okay, so in the GitHub lingo, a pull request is basically my attempt to integrate my changes into the main line. And as soon as I did this proposal, delivery came up and took over and automatically starting to work on it to make sure it's certified.
As you see, we have Bender doing our work for us, which is apropos. So here we go. We'll go ahead and open up delivery here and see where the status is. There's multiple stages inside of delivery, and I'll walk them through this if you don't know. But the first stage is the verify and approval stage. This is when a human looks actually at the code. You can go ahead and make comments on it. It's kind of like looking inside the PR, but you don't actually have to use the PR to do it. There's a bi-directional communication. But I'm just going to go ahead and say, you know what? I trust Nelson. You're a pretty good guy. I think you'll do okay. So we're running through our major lint tests and our syntax checks to make sure that shit works, right? That's probably important. So, hey, look, it approved. Cool. All right, you know what? Instead of going through the GUI, I think I'm going to use the GUI. I'm going to go ahead and prove that. Oops. Maybe I should actually click the button.
I'm sure it works.
There we go. So we'll go back to the PR here and just keep watching it here. And now we're going through the build phase. The build phase does it again. Delivery is normally designed for multiple people, multiple teams working on one system. So you can have multiple people pushing PRs in at the same time to make sure. That's the advantage of the later stages too. So Nelson here, he's still working on the things, and we're going through the lint and syntax check one more time to make sure that nothing's changed underneath us. Someone's pushed anything up to master before me doing the CI/CD pipeline thing, and we're doing it again, and we're going to eventually get to acceptance. And acceptance is what it's going to do for us at acceptance is it's going to build out before moving the code over. If you look here, as you can see, all our traffic is being served at this one location. In a moment, when we get to acceptance, we'll actually spin up, and you'll see another version pop up without no code, with no traffic going to it. So we'll actually go to visually inspect it to see if it's what we want it to be. And we should hopefully see this here in a second.
Yeah, and we also want to not visually inspect, but also use automation. And because the traffic is not being served live to the customers, but we still know where it is, we can actually apply all our automation into that, for now, private version and make sure it's actually correct. And only if that passes, then we will migrate the traffic. For this simple demo, we're going to migrate the traffic all at once. But you can do all sorts of scenarios where you can migrate part of the traffic, do canary testing as you get maybe 3% of the traffic to the new system, see how it behaves. It's up to you to define using the App Engine API console or in any way you want, how this transition goes. All right, here for the sake of time, we are going to flip everything once it's all good in a single shot.
And as you see, we're pushing out to the acceptance right now. And we should be able to see here. We also get the little chart updated here, so you don't actually have to have. Yep.
Yeah, not the one, the app engine.
Oh, it's still going. It's still going.
Yeah, where is the?
It's still going during. It's just during its functional acceptance. We haven't actually.
Yeah, and while this is finishing, one thing I'll point out, so when we talk about kind of the blending of the two, so Chef, in this case, delivery and App Engine, we're also trying to illustrate that there's a lot of power behind App Engine as a platform itself, right? So this ability to actually say, okay, here's my app entity, I'm spinning it up on top of GCP inside of App Engine.
Well, I don't know what happened.
You can
It is
do
always.
some of these things already, but the fact that you can wire them into delivery and make it part of your process, and make it repeatable, make it documented, make sure your multiple teams are collaborating. So it's cool that App Engine has that feature, and I can roll this out, test it, and then flip a switch. That's great. But that's kind of where it ends, right? The additional instrumentation and some of these other components is what we're trying to illustrate with delivery. You can bring all of that onto the front end of App Engine above and beyond just the core platform.
Jay, I'm going to call you out here. I thought Google engineers were good, and they would always get things right the first
We
time.
do. We are, well, I'm always right.
Oh, it's true.
What are we talking about right now? Okay, so let's see what happened here.
As you see, it actually failed, and that's what we were looking for, or in this example. And what we'll do is I'll ask Nelson here in a second to fix it for us.
So something got wrong. And where is not? So, well, breaking stuff is more my thing.
This is way beyond good.
Yeah, exactly. Oh, wait.
You screw things up.
I see that. Okay, so it seems I actually put the wrong link over there, which is good because our official application is still safe, right? So no.
Oh, yeah, we're tapping Dvorak.
Okay. Well, it's making it harder for me.
Yeah, exactly. But as you can see, that is our production site, that formal platform, one whatever. And so we haven't actually hurt our customers, which is awesome, right? So we actually, in the process of pushing on a new version of the code, we didn't shoot ourselves in the foot.
Yeah, so as I push another update, another attempt, this one is an awesome attempt.
Okay.
Delivery already pick the new one, is actually running with that and make sure that everything is good. And we are going to do another try. So that version obviously is broken. But now we're going to try again, and if it passes, then we will actually roll it out to production. One of the things I especially like about this delivery pipeline is allow many developers to work at once. So
should I look at this code, or should I trust you this time?
prove.
Okay, I'll prove it.
It will work.
It'll work. Okay, it's
It was
fine.
never my fault. It was somebody else's fault. So.
CDCI, no.
Exactly.
Absolutely, and we'll get through our little skit, and then we'll more than willing to show you. Trying to be entertaining, giggles, right?
Well, we can go back there while this one is doing its thing. So we can go back and show the new and improved look. And if you scroll up, you'll see that in my test case here, I put actually the wrong place. I was still pointing to a wrong URL. But my validation rules that I created that checks if my images and my environment is good, say, hey, it's not. And then tells delivery to say, stop this guy before he does anything worse. Right? So that's what happened here. Although I was good to use HTTPS, but I put the wrong link, so it didn't matter. Right? So
Oh, the security check. Yeah.
Exactly.
If you hadn't noticed, we did actually have, we do have security.
well, we didn't run because the basics are broken, so it doesn't matter, right? So
That's right, that's right.
It doesn't matter how security is if it doesn't work. So.
All right.
Yeah, but now with the fix, we can go and if you go to, where's the GitHub?
Oops.
So basically, in this process, you can actually keep all this history, and when we deliver, all this history gets actually merged together, and we also can backtrack basically later from the versions, like, okay, how did I got to this point? Like, what kind of changes it came through, right? So in this case here, we can see actually my fix. That was, I was pointing to the wrong place. Now, hopefully this is the right place.
Hopefully.
We'll see.
All right. we're going to the publish. So the publish phase in this one specific one, as we were showing, will spin up another instance inside, or another version inside of App Engine. Did I turn the mic off? No. All right, come on. We like green. Okay. We're doing the acceptance again to make sure that it's all this, the validation we're expecting it to be.
Yeah, so you can
go ahead and bring it up?
wait there to approve. No, not that one. No. Just get the, yeah.
Hey, mad props for live demos, though, right? Yeah. This is real life, right?
Things do break. Here we go, functional. Wow, this HDMI is just not happy, is it?
It's this loop here.
Yeah. Oh, there you go.
Back?
And you want me to bring up my Emacs too, 1 minute? Just on my foot pedal.
Yeah, so the way we built this demo is we created a cookbook that has actually all the unit tests and all the security tests. Mm-hmm. And we're using another cookbook that we wrote, the Google wrote, that we eventually release, that abstracts App Engine as a Chef resource. So I can now say, hey, I define my workflow in Chef, and I just say, in this case, deliver, right?
So
and then that gets done.
Nelson, do you want to go ahead and deliver it, or do you want to go ahead and check it? View it first. Deliver? Let's go ahead and deliver. Okay. So this time I'm going to go ahead and deliver through GitHub, because that's pretty cool. Comment. And as you can see, here we go.
Bender will pick it up in a second and finish that.
There we go. And it's kicking off to the union. Now, the union phase, if you don't know, is a phase that makes sure that, so everyone's approved it up to an iView. The code looks cool. Union is a dirty environment where all the people working on the code come together. So make sure that it actually works, and it works how you expect it to. The next phase after union, which is called rehearsal, is designed to be another phase where you would use something like another instance where you blow all the stuff away and rebuild it from scratch. Luckily, because we're using App Engine, we don't have to worry about that. We can just more or less kind of scoot through it to make sure it still passes all our basic integration tests and our basic unit tests. The advantage of a PaaS, if I'm correct on this one. So here we go. As you can see, we did another deploy phase to make sure it's up there, and now we're running through our functional tests.
Which now will pass.
Yes. And then now we're going to rehearsal, which, like I said, is another phase, which is designed for ground up. But in this case, because we're using a PaaS, we can just kind of be like, hey, no, it's just another union to make sure shit doesn't break.
Yeah, although sometimes those phases, they look like redundant, I think one of the important parts for them is even if a Git merge works, doesn't mean the final code is actually correct, right? So when I test my line, my branch works perfectly, it passes. And then you test your passes, but then when you bring them together, they fail. So that's why there is this extra step to make sure that when you bring everything together, they still work, right? So
this is actually to my earlier point, one of the reasons that we wanted to illustrate this with App Engine. So the first 10, 12 years of my career was all in kind of what I call the 9-to-5 enterprise IT shops, and there were times when we had 5 or 6 different disparate environments with 5 or 6 different stacks of hardware, right? Everything down from the OS and the whole way up and down the stack, you were always dealing with different levels, going through UAT and load tests and so on and so forth, right? So I think that to his point, some of this may not seem to matter as much in the context of App Engine, but obviously would matter in your other deployments using delivery, or workflow. But it's still inside of the tool, and I think it's cool to see being able to have these kinds of workflows even in a PaaS.
yeah, in many cases also, you don't have a single App Engine application. You have an App Engine with a SQL database and maybe a container running.
Nobody uses SQL.
What?
Nobody uses SQL.
My SQL?
No.
Your SQL? But that's a good time for you to test, right? So when you want to make sure that the final production goes.
And we're almost done.
I think we are done. So if you go back to...
We should wait for everything to be green, right?
Fine.
Yeah.
It's all good. Okay.
There we go. Okay. And let's refresh. Hey, that's pretty. Yay.
There you go. All right. So you have to agree. That looks a little nicer than the original one.
I agree. This is much better.
Okay, good.
You're still wrong the first time, though.
I'm never wrong. That's for the show.
So good stuff, right? Yeah, so once again, a hand for live demos for these guys. There's always going to be little hooks here and there. So like I said, a number of things we wanted to throw at you here in this session, because once again, we've done a lot over the last year, but we only have one session. So I think since a lot of you guys and girls had said you've used GCP, maybe I'll ask a follow-up question. How many folks have production workloads running on GCP? Ah, okay. So I probably shouldn't have said that, because now it makes me look bad. But it's also part of the reason we wanted to go through a few elements of GCP to tell you why you should start running production workloads with us. I'll keep this short, and we'll pick up some time, and we're going to turn it over to our friends from Cascadia to talk about the multi-cloud, because that might be something that's of interest as well, for sure. But I think the one thing that we're trying to make sure we message to folks, Brandon said this morning, and I thought it was unfortunately a very strong statement, that we don't really do marketing very well sometimes when it comes to this stuff. It's like we build these amazing products, we have this incredible cloud, whatever, but we don't really tell anybody about it. We just expect you to find it and try it out and think it's awesome. So I think that doing events like this and getting in front of folks and sharing this with you, hopefully will change that. And what we're really trying to do is, instead of getting you to think about Google like this, we want you to start thinking of Google like this, okay? And it's not obviously just search, right? There's actually 7 different Google products that each have over 1 billion active users apiece. So if you think about that global infrastructure footprint to actually power all of that, it's pretty significant, right? And so Diane Green, our new SVP, who just started kind of at the end of last year, one of the original founders of VMware, she said something very simple, but I think was very kind of poignant, if you will. A lot of people say that we've only been doing this for 2 or 3 years, but that's actually fundamentally false, okay? We've actually been doing this for like 15 years. We just haven't sold it. And it's a very important thing, because when I read a lot of blogs and a lot of analysts and a lot of folks out in Twitterverse and what have you, and all this comment about Google with 2, 3 years, there's a difference between selling it and like making money on it and actually being operationally sound at delivering it. We didn't just decide a few years ago to start making money and let's build a cloud. We decided let's externalize what we've been doing for 15 years and make money, but it's still a fundamentally different argument, right? And so I think some of the things that we always like to point out is our global network, okay? It's our fiber, thousands of miles of fiber wrapping the planet. If we were a telco, we'd be the world's 2nd largest telco. So over 100 points of presence all over the globe. Here's why that matters to you folks, okay? If you have requests coming from your applications and it hits one of the POPs that Google is inside, and Google sees it's destined for a Google resource, it sucks that request into our backbone, rises the whole way to the destination, and then the whole way back to the user. That's a lot less hops. It's running on our fiber. Usually results in better performance. So just an example of where infrastructure actually does matter, right? So in terms of the platform itself, lots of you said you've logged into it, so I won't bore you with this. You know we have almost 30 services now, lots of services, virtual machines, the whole 9 yards like everybody else. I will point out our data services, which is one area where we are significantly differentiated, because once again, it's stuff that Google's been doing for 15 years. The original MapReduce white paper that became Hadoop. I mentioned Bigtable before. Okay, it goes on and on Dremel, so on and so forth. These are all services that we're now externalizing for people to consume. So Dataproc, I didn't really put the labels on here because I figured it's not fair to just expect you to know all the products. It doesn't matter. But Dataproc is basically hosted Hadoop. You can spin up 11,000 cores in 90 seconds. Run your Hadoop jobs, blow it away. You pay by the minute for what you use. How many people in here knew that? I'm guessing, well, cool. You don't count. How about who doesn't either work at with Google or anyway? But another one is BigQuery. BigQuery is our petabyte scale data warehouse. So if you think like your traditional EDW, so Teradata, Exadata, what have you. We have a customer that has 40 petabytes of data that sits inside of BigQuery and ingests 2 million rows a second into our cloud-based data warehouse. You can do multi-terabyte queries in literally 10 seconds. Completely unheard of. But nobody really knows we're doing that on our platform, right? So I invite you, if nothing else, and I'll knock it off with the sales pitch, but if nothing else, the data services, because like I said before, there's going to be lots of clouds, and we're all going to do great things, or at least 3 or 4 or 5, okay? But this is definitely an area where we think we have a little bit of a fun road for you. And then, of course, the application runtime services and things like what Nelson and JJ were showing. So one thing I do want to point out is, as far as compute engine goes, because I figured for this audience that would probably be the most interesting, that's our virtual machines, right, our VMs. Boot up times. For folks that tried the platform out, depending on when you tried it out, in the last 6 months, we've gotten our boot times down to, well, let me ask, what would you think a fast startup time is for a VM? Anybody want to shout out a number, just a random number? 10 minutes? You expect a second? 10, ooh. Expectation, okay, that's very fair. That's so a couple of minutes. Minute? Okay. Who gets a minute? 5 minutes, 8 minutes, open stack. Okay, enough out of you. So we're down to 30 seconds now. We were at 45 seconds about a year ago. We're down to 30 seconds. I'll spare you the long story because I want to make sure we get to Cascadia as well, but a wonderful story where one of our engineers were in an executive briefing, so a whole team of executives, right? And he was up there talking about our machines, and he's like, yeah, we're working on getting our virtual machines spun up, and we got it down to 30 seconds, but we're trying to get better. To everybody in the room, they're like, okay, is that normal or not normal? So once again, it's something when you think about elastic scale, right? Spinning things up, tearing things down. These are the things that matter. We have certain machine configurations where you can get 680,000 IOPS. That's not a typo. 680,000 read, 360,000 write. Okay? This custom VMs, selecting your exact CPU and memory actually. So t-shirt sizes, we have that too. You can pick from pre-configured machines. But you can actually drag a slider and pick the exact CPU and the exact memory, and we'll tell you over time what your performance characteristics are of those VMs. So you can go back and right size the VMs as you go. We see customers saving 15, 20% doing this because they don't have to waste CPUs or memory based off of what they had to pick. So live migration, another big one. This is pretty simple. Anybody here that knows VMware and vSphere and knows like DRS and vMotion, it's essentially what it is. When we take hardware offline, you don't even know about it. It's literally completely obfuscated from anything that happens on the infrastructure layer. So very cool. Sustained use discounts. So I talk about pricing. I sometimes don't like talking about pricing because once again, on the blogosphere and with analysts and whatnot, they make it sound like Google's just trying to be cheaper. Okay, but what we're actually doing are things like sustained use discounts. So sticker price, yeah, we tend to be cheaper. But what sustained use discounts do is the more you use the machine, we discount it more because then we can plan for what our underlying infrastructure looks like. So it's once you get over, I think it's like 20 or 30% of the month, we start slapping more money off the price. And it happens automatically. You don't have to sign any deals, you don't have to sign any contracts to get this or anything, it just automatically happens. And you can shave up to 53% off of that virtual machine. Now if you're sitting there and you're thinking, well, I don't really run all my VMs 24/7, 365, we actually aggregate it for you, once again, automatically. We call it inferred instances. So if it's the same machine type and you're spinning it up and down and up and down, and another one that's the same size up and down, we'll actually aggregate them and still give you the max discount. So pretty cool stuff. And this is just marketing. So storage, no, we're cheap really. So from a storage perspective, so our object storage, so we do object storage like everybody else. We're probably a little bit cheaper. But the one area that we really, once again, I want to let you guys know about differentiation is with archival storage, right? So think long term, like slow-moving blocks of ice, like that kind of long-term. Or tape. Thank you for that, sir. So we call it nearline, okay? So it's a penny a gig a month. So hey, pricing, that's really awesome. But here's the key. It's the same exact API footprint. So if you code to our standard storage API, and then you want to code to our archival storage API, it's exactly the same. You just change what the tier is. It's one property. That's it, you're done. Whereas even a bigger deal is time to first byte. You don't issue an API command and come back 6 hours later after lunch and dinner, maybe. Okay? 3 to 5 seconds to the first byte. So we even talk to customers that are using this because of the price point for some of their standard web tier assets. Because maybe, it's all use case driven, right? Maybe it's not going to annoy the user to have to wait 3 to 5 seconds, and I'm going to save a boatload of money on the back-end storage. So you can do creative things like that as well. And then finally, security, I'll just hit this really quickly because I'm surprised, I shouldn't be. I was surprised at how many folks just defaulted to Google and the rainbow colored logo and doing consumer and not taking security seriously. Here's what I will tell you. If we engage with you and if you reach out to Google and we start having conversations, we bring in the heavy guns, and I don't want to say I promise you, but our story around security, when you think of the assets that we have to protect, and that's what we're extending to what you're consuming off of our platform, security tends to not be an issue, okay? We have over 500 engineers, and that's just engineers that focus on security 24/7. We found Heartbleed before anybody else even knew about it. We were patched before the public announcement. Okay, these are the kinds of things that we do day in and day out. So there's a whole half a day or full day we could spend on this, but I just wanted to throw the nugget out there because sometimes for whatever reason people default to Google just kind of being this fun little thing hanging out there. Security is not an issue. So, sorry if that was a little bit too much. I don't know if I went too far on the high level marketing-y stuff, but I wanted to make sure that everybody understood that if you're hearing about Google Cloud, if you've logged in and tried it out and okay, fine, it's cute. This is something very real for Google. It's something that for us, we're running all of Google on it. So it's not like we're going to shut it down like Reader. That's the other one, yeah. See, there you go. At least I threw it out there. Okay, fine. How about this? Wait, how did it go? We didn't do that to hurt you. Was that the keynote this morning or whatever it was? It wasn't, anyway. So we want to make sure we give ample time to our friend from Cascadia, Michael, who's going to come up and tell a little multi-cloud story about what they've been doing with customers. And hopefully it'll be relevant to some of the things you guys have in your plan. So, next up. And you have a lavalier. I don't have to give you this, right?
Did get quite a bit of flack for that one, by the way, so I just want to point that out. I'm going to go through this fairly quick because I'm actually going to give you a live demo of a real-world scenario, which is pretty cool stuff, if I can actually get it up and running. So I'm Michael Noring, I'm with Cascadia. For those of you guys that don't know Cascadia, we're basically a DevOps cloud engineering and managed services company. What does that mean? Well, it basically means that if you're going to do something on the cloud, you're only going to do it if you're going to actually automate, right? We firmly believe that it's all about the automation. So we often go into organizations and help them actually understand how to use things like Chef, how to get things deployed, get them up and running on the cloud. And then we also do managed services after the fact, which means we keep all the engineers in bed. You guys can help, continue building out. We'll have your back so you guys get some good sleep is pretty much the way I put it. All right, so the example I'm going to go through, as I said, is kind of a real customer scenario. The first thing I just want to call out is we heard a little bit about the CIO at Alaska talk about how you had these business outcomes. And I will say the number one thing we see when people are being successful is they focus on the end game of what am I really delivering to the business, not, hey, look at this really cool technology, right? Now, we're all technologists here in the room, so we all love the technology, we want to tell the story, but when you then try to go get them to give you money to do it and they give you commitment to it, you always have to tell a different story. So I'm going to kind of give you a demo that very quickly takes you through the story in itself. So this kind of represents, you got to have a vision, and then you overall what you're trying to do as a company. You got to have a business architecture where you're trying to achieve an overarching technology architecture. And then at that point, you can worry about the technology itself. So I'm going to try to tell that story kind of very specifically with what most of us won't necessarily consider that exciting, which is nonprofits. Now, the reason why this one is very interesting is we're not talking about one singular nonprofit. We're talking about the G8 summit basically mandated that all nonprofits open up pretty much all their research and start collaborating and all of that. Well, as you imagine, you have all these different organizations that are basically storing information everywhere, and they have nowhere to communicate. As a matter of fact, most information is sitting on things like laptops. A lot of it is sitting on pieces of paper, so it becomes very difficult. But really, from a vision perspective, it's how do we actually use technology to start sharing all of this and actually do it for global good? And that's really the story that I'm going to tell here. So what is realistically the problem? The problem is that there is literally petabytes worth of data just scattered across all these different kinds of organizations. Everything from when they're collecting it, it's everything from little internet devices sitting scattered across with sensors on them that need to get pulled in, geospatial information that is in the petabytes. And then also what I'm actually going to demo is, suppose I'm standing somewhere in Africa and there's absolutely no internet. Rather than using paper, I'm going to use a little telephone device and basically be able to, on the fly, submit information and then have that available immediately for the whole world to see. And that's a little bit what we're going to demo in this specific case. How do I then make it shareable, published, or discoverable for other people to come in? And how can they immediately publish and start looking at it with various different analytical tools? And how do you provide that in a completely integrated way in such a way that their business or the people that are the researcher can on the fly actually deploy these applications without even calling IT? Pretty powerful stuff, because underneath the hood is all the tooling we talk about today. And the reason this thing is multi-cloud is every cloud provider has some specific thing that makes them extremely valuable. But how do you tie all these things together? And one of the secret answers to that is actually Chef is a real key component for a lot of this work. So what I'm going to demonstrate, and this looks really messy, but it's going to be very hard to kind of show. So public clouds, as you can see, it's actually storing a lot of information that's coming from multiple different organizations. And it's not that we're controlling that plane, but we are taking a look at all that information, indexing it, and pulling it together. There's some curious ones in there like Joyent. So because they do a lot of geospatial and they got to do a lot of calculations, they actually do inline right there along with it. Google is a very key component, and there's some other guys there too, including even things like private storage. A lot of that's because a lot of this information, there's all kinds of rules around, does it have to stay in a country, data sovereignty, and all that stuff that has to be accounted for as part of it. As you can see, I have various different tools that you'll plug up to. I'm actually going to demo what's called the ODK, or Open Data Kit. And S3 is a big analytical tool. The automation bit is what I'm also going to demonstrate in terms of what Chef is doing. So it's kind of an oversimplified picture, but I tried to make it as simple as I could, and it actually looks very confusing. So apologize for that. All right, so this is the scenario that I'm actually going to go through, which is basically the first thing I'm going to do is a researcher's going to log in, and they want to set up that field research, and they want their field research to be able to run around on this device right here. But they also want it completely pre-integrated. They don't want to worry about how do I make sure it makes this into some kind of storage mechanism that it's backed up and it's safe. And I don't even have to worry about how that actually is connecting the other end. So that's what we're going to go through here. So the first thing I'm going to do, if the internet works correctly, is I'm actually going to log in. This is a simplified portal, I should say. So we actually had to run this on a kind of a separate instance. But it's a simplified portal. And as you can see, I only have a couple of things, data source, portal, and search. The first thing I'm going to do is, just to make sure you guys see, I'm going to type in demo, because that's actually the research we're going to do in the field. And it doesn't come up with anything, just to show that I didn't have any tricks up my sleeve. If I go to the data source portal, this is where I would go to say I now need to have that research in the field going on. And the business would go in here and they would basically just deploy their new data source. I'm going to give it a name of some sort. Let's just pick something like, let's say, Cascadia. Now, I actually now choose what application I run. Remember me talking about ODK. So a lot of these researchers know, well, I know ODK and I know what that is, and I want to use that. They're just going to go select it. It then selects what cloud provider actually provides it. So in this case, and actually ODK runs pretty natively on Google. It actually is one of the really nice things is how well it's integrated with it. I get to pick what zone, which is extremely important. And the reason why this is important is if I'm standing in Africa, I don't want the latency of dealing with a server in the US. I want to get as close as I possibly can to that. So I'm just going to pick, let's pick US Central 1A. I can also now pre-populate. So not only can I stand up a server, I can move in the ODK, I can actually also pre-populate it with forms that's been created in the past. So that means that not only am I getting an application, but I'm actually getting functionality I already know that has the surveys that I want on it. So I'm going to select demo. And I also get to select, finally as the last one, how do I actually want to run it? I'm going to run it in development in this case, but think of it this way. If I'm picking production, it's going to have very different rules in terms of moving all this data and start making it available to a broader audience. So I'm just going to pick development for simplicity. And I hit deploy and cross your fingers, nothing went wrong. You'll see it start spinning. So right now what it's doing, it's actually spinning up a server. If you don't believe me, it's sitting right here in Google. So it's actually now gone out and it's starting up a whole Google server and it's starting to go through everything it needs to do to configure that server. Now it's going to take, I don't know, not 5 seconds, probably a good 30 seconds for the Google bit and probably just a little bit more for Chef to actually basically configure the server itself. So I just want to note what's going on right now, and it's kind of chicken scribble a little bit. But what's going on is that the automation has kicked in, a Google instance has been set up, and the node basically calls Chef Server. Chef Server is figuring out what cookbooks are coming in, and it's now starting that configuration. First, it's going to put in ODK, make sure that that's set up appropriately, make sure that's completely configured. It's going to go pull those forms, which is an ODK specific thing that it's doing that we're going to publish against. And it's setting the whole thing up. And it's actually going to come and tell us when it's done. So right now we all have to sit and wait. Now, while we're doing that, we can play some elevator music. Not really. I just have to configure this thing right now. And what I'm going to configure it to, if I go back to the object storage, you'll see that I actually get a URL that I can now call for that server if I'm on the business side. So I just have to type in the URL, so give me a second. Oops. This is where fat fingers come into. And 196.
That's the good time that we are not in a hacker conference, otherwise that URL will be attacked by a lot of people this time.
There you go. All right. So yeah, you definitely don't want to attack that one. So as you can see here, the CPU on it is actually going up, and that's because it's doing a lot of processing right now. You'll see a dip when it finally gets into place, but we have to wait here a second to kind of see.
Who here is counting to 30 to see if I was BSing?
Well, I will actually warrant that right now. If I go in and actually look at the instance, just to your point, and we look at the logs, I actually think it's completed its run from the Google perspective. See? So now it's Chef's doing its work. Now we're waiting on Chef. So I just want to point that out. Google has done its job.
Made him go there.
So I apologize. This is where you just kind of have to sit and wait a little bit, but it's actually extremely quick if you think about going in, setting up an entire server, filling it with the application, pre-configuring everything, and actually making it so they can communicate into this entire network of a multi-cloud solution, right? And then includes where it's actually going to store this information. So the interesting thing here is that it's actually, we're using Google for the application, but it's actually storing it in AWS. And the two are actually interconnected completely, so it's seamless, nobody having to worry about anything. And everything is done on the fly. It's not like we sat there and stitched them together manually. Everything is automated, right?
And maybe think once again, if we're driving home one key point, once again, about open ecosystem, and us not having to win, I think he made a great point. Each cloud provider is going to have things you might find more valuable than the other. And so a lot of times what I had seen, especially in large enterprises, they try to find this abstraction layer, and all they really tend to do sometimes is just dumb down each individual cloud provider. So this is once again an example of where, and I thought you put it a great way, everyone's going to have its strengths, everyone's going to have its weaknesses, you pick and choose accordingly. We'll let him end with the big kabang, and then we'll let you guys go since we're not.
So-
But real quick, and that was,
Yep.
take the whole thing. We do have coupons over here, special code to get you $500 to get started instead of our typical little try it out. So come back and see Brandon when we wrap up here. And you have $500 to get started. Obviously, feel free to reach out either to your chef reps or your local Google reps will help you out. But please, go ahead, take it from there.
So,
I just felt bad.
yep, so you can see I actually now launched the ODK. It's up and running. It has no data in there because I haven't filled any forms. I've actually just filled in the forms on here on the device. Imagine me standing there next to some big lion filling in a form, right? And then all I do is I hit save and exit, and it's already been shipped off. And so if all I do in here is I refresh, there's my form. Now, what I'm having to do here real quick is we're going to take it a step further. Is I'm actually just going to jimmy rig the system. So ODK is set so that it uploads to it every 8 minutes, and we're really not waiting 8 minutes. So I'm going to go on the forms list, and I'm just going to basically force it to release the data. And I just need to update a couple of things, and I can hit publish. It's going to make sure that I'm not some random individual doing something. And I can now see that I've actually published this data. Now, here's where it's important. If I go back to this, remember this whole UI that they're actually working with on the business side? I can now go in and I can actually search for that form. And there it is, right? So this is basically where they're capturing the raw data. So everything I'm capturing on this device is now available, stored in the cloud, in this case AWS, and is now available for consumption. And we're just going to make sure, is it there? Not yet. Takes a second. There it is, showed up. So here's what's important, is now I can take that data, and imagine somebody standing there on the ground and they're entering the information, and immediately somebody who's, let's say, sitting in the States can then say, okay, let me actually look at what's going on the ground. And I'm using S3 in this case. I'm actually just, whoops, I'm using a plugin for S3. As you can see, here comes the point, brisket time. I'm a brisket lover, so what can I say? And because it actually also had geospatial information, it actually pinpointed me where I'm standing right now, right? But imagine all the information you can capture, and the business does not know anything about what's going on behind the scenes, right? Kind of as they talked about Alaska Airlines, is it should be completely invisible to everybody. But what's going on behind the scenes is a tremendous amount of work and automation that just seamlessly brings it together. So that's basically it. That's all I had. Hopefully that makes sense.
So 2 lines.